so have a go at the question here. This is SOHCAHTOA. Take a minute to solve. I'm gonna go through. Computer distraction it.
Oh, I'm just gonna go to my class.
Can we just close it and focus on the lesson? All right, so let's have a look at how to solve this one. It is fairly straightforward. If you remember from previous courses, we use SOHCAHTOA to solve right-angled triangle trigonometry problems. So you have the acronym. You have the acronym SOHCAHTOA. And it's normal to write them in these sort of triangles like this. They make it easy to use the formula. Next up is we have to label the sides of the triangle. Can we remove the headphones, Albert? So you have three sides. You have the hypotenuse, the opposite, and the adjacent. Which one is the hypotenuse? The longest one is the hypotenuse. So we label this H. So what we need to do is, we're not using SOHCAHTOA, I just read the question. It's not trigonometry. Okay, how did I realize it wasn't trigonometry? Well, I looked at the triangle and realized we only have one angle, the 90 degree. We don't have another angle. So at that point, unless we're trying to find the angle, if we're given two sides, then we're going to be using Pythagoras' theorem. So Pythagoras' theorem is c squared equals a squared plus b squared, implies that triangle ABC is right angled. So if triangle ABC is right angled, then c squared equals a squared plus b squared. If a squared if c squared equals a squared plus b squared, then triangle ABC is right angled. So what we can do for this one is the hypotenuse is always your c, so we put in 15 squared is equal to 7 squared plus b squared, and this is the length we're asked to find on this one. We can end solve this on the calculator. Let me do an end solve of this one. So menu, algebra, end solve. We want 15 squared is equal to 7 squared plus b squared. Solve for b. We get 13.3. So b is equal to 13.3. Check the units, centimeters. Make sure you practice on your calculator when we do these problems, typing it in on your calculator, pressing the buttons. It's kind of like you're sort of rote learning how to do it. And it's the same sort of thing you should do with your house keys, is always put it in the same place as you come in. So you do it without thinking. Otherwise, you're one of those people that always says, "Have you seen my keys?" Don't be one of those. Just drill it into yourself. It's simple. Okay, determine whether or not the triangle with sides 6, 8, and 9 is a right-angled triangle. So this is what we call the converse of Pythagoras' theorem. If we look back to the theorem, I wrote it in the converse. So if this is true, then it implies that it is right-angled. So we can solve this in the same way. What we first must say is that 9 is longer than 8, which is longer than 6. This implies that 9 is the hypotenuse. It's really obvious. It's basically me mathematically reasoning which is the longest side. So if this is right angled, it would imply that 9 squared is equal to 8 squared plus 6 squared. We can test this on the calculator. We're not end solving this one, we're just going to test it. If we say 9 squared is equal to 8 squared plus 6 squared, you'll get one of two answers from the calculator. The calculator will tell you true or false. So if it's false, that means that this is not a right angle triangle. If it is true, it means that this is a right angle triangle. So this is false, which implies it is not right angled. Not necessarily.
So we can get like an equation of this equation.
Oh, definitely. A lot of the time we will.
But just for this one, like, would you start to test it? Because this one's, like, if you try to calculate it yourself, you just like 8 squared plus 6 squared.
As soon as you see the numbers, you're like, this one's 81, the other one's 64, and then 6 is like, well, that's 36, so you can sort of see it. You can just calculate it. But for instance, if you tried 17, 15, and 8, is that one right angle? 17 and 15 are quite close, but when you square them, it's far enough apart for the 64 to work. Have a look at the reasoning. So in the reasoning, often with your reasoning, you need to use inequalities and show this is bigger than, even if it's really obvious. Say that 1 is less than 2. That's why whatever your question is asking to explain. Have a go at this one for yourself. Sorry, I'm going to ask if you can close your computer and take out your notebook and move it back from the desk and try and catch up with those. Okay, let's have a look at the solution. So we've got this vegetable plot with a right angle triangle, and he measures the sides. He wants to see if it's right angled. So we say that 145 is bigger than 144, bigger than 17. So we are going to try 145 squared to see if it is equal to 144 squared plus 17 squared. 145 squared is equal to 144 squared plus 17 squared. And this is true. Oof, I didn't know that Pythagorean triplet. Look at that. There's only one number apart, and that's still 17 squared. which is 196, isn't it? Which implies it is right angled. So this is our answer for this one. Okay, let's do a review now of trigonometry. So when we're looking at trigonometry, we do have the three sides of a triangle. The longest triangle is always called the hypotenuse. And usually in the problem, we indicate one angle as a reference point. The two sides of the triangle are often called the legs of the triangle. So the two legs of the triangle, there's no difference between them. They don't have a specific name. Only the hypotenuse has a specific name. But once we reference one angle on the triangle, then we need to reference what the sides are in relation to that angle. So this side here lies opposite the angle. This side here lies opposite the angle, and the other side lies adjacent to the angle. So this is how we name them. Let's have a go at the naming technology. So typically with an angle, we call it theta. We use this symbol here, the Greek letter theta. Various parts of the alphabet are used for specific purposes in math. We tend to use for variables, x, y, and z. We tend to use constants, a, b, and c. We like k as a constant as well. If we have an integer variable, we use n, m. If we have a function, f, h, g. Angles start theta, alpha, beta, gamma. We use the Greek vowels, in fact, for that. Okay, have a go. Copy this picture down. Sketch the triangles in different positions and see if you can name the sides. This is only adjacent. The angle is the marked angle, so mark the angle A. Here on this one, you need to mark the angle. So which angle is that one that you're referencing? So like this. All right, is it this one?
Yeah.
Is it this one?
Yeah.
Okay, so then it's wrong.
Or the next one is these two.
Yeah.
Yeah. Oh, I looked at it wrong.
Is that wrong? This one is good. This one is good. Okay, have a go at the exercise now. Let's have a little look. So here on this one, which is your right angle and which is your reference angle? So that's your right angle, which is your reference angle. Where's theta? Where in your diagram is theta?
What's theta?
Notice the little circle with a line through the middle?
Oh, right.
Okay, so if this is theta, then this is wrong and this is wrong. You've got two lines there. Well, show the right hand. Try to see the right hand. Okay, so that's wrong.
No, I'm confused. I was waiting for
I see it on the
Huh?
I see it on the
The right hand is wrong.
Okay, so that-
The right hand is wrong.
and
And then you've got some of the shorter legs. That's the
Yeah,
hypotenuse.
it's like when something on it. No one says.
Yeah, do you not have any writing materials for today?
I should have. I was just looking.
No, to write all these things. These are powerful.
I think I don't have it.
Yeah, let me go through this now. So firstly on this one, here is our reference angle. This side lies opposite the hypotenuse, so it's the hypotenuse. So if we have the angle here, this one becomes the opposite, and this one becomes the adjacent. On this triangle here, 90-degree angle there, so this one is the hypotenuse. The reference angle is here, so the opposite lies opposite there. The adjacent is the last side. The 90-degree is here, so this is the hypotenuse. The reference angle is there, so this one is the opposite, and this one is the adjacent. Naming your triangles clearly, drawing them well is essential to getting it wrong. Some of you get your problems wrong because you draw a sloppy triangle and then forget which one is the right angle. Making more effort with your notes will lead to greater success. Making your diagram bigger, not trying to cram it into a tiny place, will make it more successful. So if you remember you should remember from your SOHCAHTOA, we have SOHCAHTOA, and this means that the sine of the angle is opposite over the hypotenuse, the cosine is adjacent over the hypotenuse, the tan is opposite over adjacent. I like to write them as little triangles like this one. I don't know why I'm starting with that one. Let's give it a SOHCAHTOA. Like this. If you have two of the sides, you can use these triangles to find the third piece of information. I will show you how to do it now with this one. So we need to find the size of angle A in the triangle given. So we see that angle A is here, so this is where we're placing our theta. We can use any of the three ratios to find this one, so we'll start with this. Sorry. Let's try SOH. This means that the sine of the angle is the opposite over the hypotenuse. So let's label the opposite. The opposite is going to be this one, the hypotenuse is going to be this one. So it tells us that the sine of the angle is equal to the opposite over the hypotenuse. So the sine of theta is equal to 3/5. We can end solve this if we want. So there's two techniques at this particular point. So one technique is to use end solve to get to our solution. And we can just go menu, algebra, end solve. And then the trigonometry buttons are down here. We need the sine of x is equal to, and then pull up a quotient, 3/5, comma, solve for x. And we'll get our answer. The important thing to note is if you open up your calculator now, try that for yourself. Try this for yourself.
What did you appreciate?
So if you want to start with the menu, and then trigonometry. Can you see why you don't have the same number of lines? Yeah, that's right. Three lines. That's the truth about that. Gotcha. So, conclusion to this. Control the arm.
Past 7. And then she says, oh, we're not moving.
Have a look on your calculator.
No, usually the time that you do what my sister's just like, no, let's try my luck today.
Fix it. Yeah, the battery's dead, so what probably happened is it's stored and left in a hot place, when we left it in a hot car, the battery is now useless. It will, the calculator works and everything, but the battery retains no charge. Good, that's it. I'll fix this quick, we're halfway through the slides. Let's have a look, yeah, how are we doing? Looks good, you got your thing. Gotta bring it to class.
So it doesn't show.
I did it over your shoulder. All right, so this gives us that, what was our answer? Theta is 36.9. Theta equals 36.9 degrees. The important thing to check with this is the degree symbol here, that it says degree. You can scroll up with your mouse and you can click on this one and it will move between degrees and radians. It should be degree. If your answer is tiny, if your angles are less than 0 or around about 1 or smaller, you're probably in radians. There is another technique to this problem. So if you're not using AISL, it's a little bit quicker. And what you would do is just take the inverse cosine of both sides. So it would leave us with theta equals sine to the -1 of 3/5. And it's a little bit quicker on your calculator if you want to use this technique. So we say trig sine to the -1, and then we put in our quotient, 3/5. And we get the answer. So we rearrange, if you're finding an angle, you use the inverse sine trig functions. If you're finding a side, you use the regular ones. Yeah. From function notation, meaning to the inverse function. No, let's wait until other letter changes. Have a go at this question here. Are we getting?
So I just named it, make it easier.
Not looking good so far. Yeah.
So. Sorry.
Which side are we at?
Right to this side.
Legal question. No. No. Yeah. Which side are we after? Okay. Where's the reference angle? What's the sign? What sign's the angle? How many degrees?
So,
No.
It's still clarifying everything.
Which form are we gonna put it in?
It's a total.
yeah.
Okay. Yeah, have a look. Okay, let's have a look at this one on the board. First thing to do is to label the sides that you have. This is the hypotenuse. Here is our reference angle. Next, look at the question. We're after GH. So GH is this one at the top. Where does that lie in relation to? Where does that lie in relation to the angle given? Adjacent. So if we write our SOHCAHTOA, like this. I have an angle. So I have this. I have a hypotenuse. So I have this. And I am after an adjacent. So I'm after this. Which one is the complete triangle? Put your hand over the yellow bit. So the formula is the answer is that times that. So with this technique, if you put your hand over the yellow bit, it would be opposite divided by tangent of the angle. On this one, it would be sine times the hypotenuse. And on this one, it's the cosine of the angle times the hypotenuse. That's the purpose of the triangle. So it rearranges the formula for you. So line segment GH is equal to the hypotenuse times the cosine of 52 degrees. So we get 14 times cosine 52. Look at my answer. I tend to, when I'm doing problems on this course, I have my calculator set for 3 significant figures. That means float 3. Notice how my answers have been 3 significant figures each time. How many significant figures do we see here? That is the most annoying feature of this calculator, is if the final significant figures are zeros, it doesn't show them. So instead of showing 3 significant figures, it shows 2. So this is the most annoying. You realize that you're using 3 significant figures, and it should always be 3. If it said 8, it would mean 8.00. In this case, it says 8.6. So the answer is 8.60. It cuts off the significant figures below if they're all zeros, all of the zeros. Let me just prove that to you. So if I go document 7.2, wait, I was on fixed. Oh no, I wasn't on float. I've been doing AISL, sorry. Okay, 8.62. It is still true that if it was on float 3 and I got 8.6, it would have been 8.60.
No, it says 8.60.
It's actually 8.62 because I thought my calculator was on float 3, but it's on fixed 1. Good lesson to learn is to check at the start of your lesson which method it is. When I'm working with my other course, IM2, it's 1 decimal place. So I have that on fixed 1 for that one. All right. Still watch out for that. If you are using float 3, just to round your decimals, and it is the recommended setting to have for this course. When it comes out as less than 3, it's because they're zeros. You can check by having it display more digits. Okay, let's have a go at this one. Okay, for this one, we are given the angle here at A, so let's mark the angle as being 40 degrees. We're given the length of the base, and we're asked to find the height here of this one. So the height BC, find the length BC. The length BC is going to be the opposite. It lies opposite. So if we look at our TOA, the ones that we have are the angle and we have the angle and the adjacent. The one that we're after is the opposite. So we want to use tangent for this one. This tells us that the opposite, which is BC, is equal to the adjacent, which is 15, times the tangent of 40 degrees. We put that into the calculator, what did we get as the answer? 12.6, and what's the units? Meters. A very small tree if it's this big. All right, a couple of bits of vocabulary on this one. It's angle of elevation, angle of depression. So if you're looking at a particular point from the horizontal and you have to look up at something, that's an angle of elevation. If you're looking at a particular point and you're looking down at something, that's an angle of depression. So key words that you need to learn for this one. Make some notes. Okay, moving on. Okay, this is a little bit more complicated problem. Have a go at this one in pairs.
In pairs?
Yeah. It's our last problem for today. Should take 5 minutes. those are questions. Copy down the diagram, try and solve it.
Bless you. Bless you.
So it says the angle of elevation and depression is the top and the base. So we're standing here at A. So there's one that's going up and there's one that's going down. So of the top and the base are 55 and 18 respectively.
That means individual.
No, that means that it's in the same order that they said them in the earlier clause of the sentence. So they say top and base, 55, 18. So the elevation is 55, the depression is 18. Yeah. Yeah. Depression is going down.
So from A to E is 6.15.
Yeah.
I don't understand what they're asking.
You're finding the height of the building
Oh, so that's
from D to C. Or CD.
No. To find this triangle, you have to do this. Oh, yeah. And this one, so you have to find 18.
You want to find the common side, because then that will give you a piece of information for the other triangle. See, we have a common side for two triangles.
AD. AB side.
Yeah. Can you see? Because that will then give you some information about the other.
So we should add these two.
You already have BD.
You can combine the two triangles by adding the degree.
You can. But for such privileges, turn up on time.
Oh, yeah.
Try and solve problems. Talk a bit less. Sorry, you want.
So it's like.
What the angles of elevation?
I'll go through it in half a minute.
So are we supposed to like find
The height of the building.
from ED? Like,
No, from C, B, and D. You have to find all the buildings right there. Three points at C, flat points at D. So what do you find? C, D. So basically, you're going to find C, D. Okay, on the other.
Oh,
I don't know how to get it.
all right, let me do it on the board. Should have finished this by now. Let's see whether you got it right. Or let's see whether you picked up any kind of a point. So from this studio window, which is 6.5 meters above the ground, so he's here, Tom views the top and the base of the building on the street opposite. The angles of elevation and depression of the top and base are 55 and 18 respectively. So that means this one is 55, this one is 18. Find the height of the building he is viewing, giving your answer to 2 decimal places. So we are looking at finding this length here. So we've got 2 triangles. Our first triangle is this one. It seems to be at the beginning, we don't seem to have any information other than the angle, but you'll notice that this height here, these are horizontal lines. Remember that the angle of elevation and depression is from that green line, which is the horizontal. So this is the horizontal. Angle of elevation is up, angle of depression is down from the horizontal. If this line here is horizontal and DE is also horizontal, then this length is 6.50. Just looking straight across. So now we do have 2 pieces of information in that triangle. We have the triangle, let's draw it like this one, it's A, B, D. This angle is 18, this height is 6.5 meters, I believe.
Yes.
So what we want to do for this one is we want to find some more information. So it looks like we don't really need this triangle because we already know this part and all we need to find now is BC. But if you notice to try and find BC, there's no information in that triangle. But the 2 triangles share a common side. The line AB is common to both triangles. If we can find the line segment AB in this triangle, which is the adjacent here, we'll be able to find the length BC in the other triangle. So let's start off with this one. We have an opposite and we have an adjacent. So we want the TOA. We're after the adjacent. So the adjacent, which is line segment AB, is equal to the opposite, 6.50, divided by the tangent of the angle, which is 18. Pop this into your calculator. So on our calculator, we want 6.50 divided by the tangent of 18. Look, I got 20. Let me just do my document 7.2. So this is the thing. It is in float 3 this time. If I put it in float, you'll see why I get 20.00. So this is where the calculator does that annoying thing where when it's in float 3, it rounds it. Now, listen carefully on this one. If on my next calculation I use the length 20, you will be getting an inaccuracies. This is when we write our answers down, we show them to 3 significant figures. But when we use them in our next calculation, we need to use all of the significant figures. So for our next calculation, we're trying to find the length CD. So CD is here, it's the opposite. So the opposite is equal to the adjacent times the tangent. So we want 20 times the tangent of the angle, which is 55. We write this on our paper, that's fine. But we don't calculate like that. You scroll up like this to the number that you want, and you use the exact value like that. So just scroll up and press enter, and it will copy it down to wherever you are in your calculation. And then we use the exact value. That's 55. Particularly if you're doing this with exponential type equations, then it really exaggerates the error massively. So on this one, our answer, let me put my document back into float 3. This is 28.6. Okay, is that the answer to the question?
one cube. I mean, one area.
So the question wants the height of the building, doesn't it?
Yes.
When you finish a question, get used to just giving the question a quick scan over and say, what was the question? Because once you put your head into it, you'll have forgotten what you originally read. Just give it a quick scan. So what was it wanting me to answer? And it wants you to add these two together. So I'll just take that number and I'll add 6.5.
6.5.
35.1.
How is it 6.5? And then 20.0.
20.6 plus 6.5
Sorry, let me
Oh, okay.
write the calculation for you. So we've got 6.50 plus 28.6 is equal to 35.1 meters. Okay. Use the time in class now to work with exercise 1G, 1H, and 1I. Alvin, you want to go to the bathroom at that point?
And then I'll come back.
I said yes.
Open up your textbook. Do these questions now. You guys are struggling with this topic far more than I would expect of a class in grade 12 on this